All right, so we're going to take a look at section 2.1, and maybe part of something else. We'll see. So first thing I want to do is just graph that and see how many times it crosses the x-axis. So I'm going to type in 2x cubed minus 3x squared minus 3x plus 2. And I'll start with zoom 6 and just see how that window looks. Okay, I think I typed in something wrong. Let me double check. 2x cubed minus 3x squared. Yeah, I meant to put minus 3x plus 2. Okay, now it's good. Okay, and that looks like a good window. Okay, I can see everything that I need to see in that graph. Now, how many times does that graph cross the x-axis? Yeah, it crosses 3 times. And the fact that this number right here is a 3, they don't have to match all of the time. But this number tells you the max number of times that it could cross. Notice I didn't say it is the number of times it crosses. It's the maximum number of times it could cross. Okay? It's the highest exponent. Generally, we like to put the highest exponent first. If it's not first, you might have to look somewhere else. But the highest exponent will tell you the maximum number of times it could cross the x-axis. Now, what's the y-coordinate for any point that's on the x-axis? Yep. 0. Yep. The y-coordinate for any point on the x-axis is always 0. So what I want to do is look at what I have written right here with these 3 sets of parentheses. And I want to compare it to what I have up top. So I'm going to graph this in y2. Exactly like that with those parentheses. And we're going to look at how the picture of that compares to the one we already drew. Let's put in x plus 1. Let's put in 2x minus 1 and x minus 2. So how do the blue graph and the red graph compare?
They're the same.
They're the same. Okay. How you would get that, that's a little tricky. We're not going to talk about right now. But the important thing to understand is what I just typed in here and what I typed in up here are exactly the same thing. This version of it, that's written like this, makes it a lot easier to answer the question that they're asking here. They're asking you to take that equation, set it equal to 0, and solve it. Now, if you tried to do that with this top one, set this equal to 0 and solve it, your first step would be to turn that into that. Okay, which again, we're not doing that today. I just want you to see why this makes it easier to answer this question. Now, let's pretend that you can't even see what's in those parentheses. Okay, what's in them doesn't matter right now. All we know is that we're going to be multiplying 3 things together, and we're setting it equal to 0. Why 0? Well, that's what they told me to do right there. So what would have to happen if you multiply 3 things together and you get 0 as the answer? Yeah?
They have to cancel each other out.
So what do you mean? How do you multiply three things together and get an answer of 0? Yep.
Well, you have to like put in a number into each equation so that each set equals 0, so that they all collectively equal 0 because they're multiplying each other.
So how does that, so like in math, when you get an answer of 0 from multiplication, what must have been the original problem? What must have been in the original problem? Yeah? A 0, right? The only way you can get a 0 with multiplication is if you multiplied 0 times something. Right? So in order to multiply three things together and get 0, either this one has to be 0, that one must come out to 0, or that one. Not all of them, but at least one of them must be 0. So if we take and set each one of those factors equal to 0, it is going to tell me the answer to the equation. So set each one of them equal to 0. And what would you plug in for x that would make the first set of parentheses 0? Yep. -1. So if you fill in a -1, this one will be 0. I don't care what these other ones come out to. Something times 0 is definitely 0. So -1 works. What would you plug into the second set of parentheses? Yeah? 1/2. Yep. And what would you plug into the third set of parentheses? Yep. 2. So now, I don't need the same graph twice, so I'm just going to get rid of one of them. And I want you to watch where the graph crosses the x-axis. Okay, and if you can't see it, I'll zoom in so you can. Looking at those answers that we just got and comparing it to where that line crosses the x-axis, how do those answers compare?
They're all spots that are getting crossed on the
Yeah. When we set this equal to 0 and we solved it, we were basically finding all the numbers where that graph crosses the x-axis. Here's your -1, your 1/2, and your 2. So that's what it means when you set an equation equal to 0. You are finding where it crosses the x-axis. So in the problem we just did, we got 3 different numbers. Those 3 numbers that we just got are called the roots or the zeros of the equation. They're the numbers that you can plug in for x, and you'll get 0 for the answer when you do that. So another name for them is also called an x-intercept. Generally, if I ask you for an x-intercept, that is a coordinate. So if I asked you for the x-intercepts on the last problem, you would say, just go back to it, -1, 0, 1/2, 0, 2, 0. Those are the intercepts. The roots, or the zeros, are -1, 1/2, and 2. Doesn't matter what order you list them in, but you would have to list all 3. So any question on that idea of how setting an equation equal to 0 allows you to find the x-intercepts? Now for this problem, it was all dependent on being able to take this, and write it like that. If you don't know how to do that, you're not going to be able to do this algebraically. Okay? So that's something we'll talk more about. Right, so now let's think for a linear equation. So we're gonna step back from a cubic. That's the one we just did. We're gonna look at something a little simpler. Linear. Linear equation. The highest exponent is a 1. Okay? Normally, when it's a 1, we don't even write the 1. We just write ax plus b. If you wanted to get x by itself here, how would you do that?
Subtract b
Yep.
to both sides and then divide. Wait, you said x, right?
Yes.
And then divide both sides by a.
Yeah. You would subtract the b, and you'd divide by a. That's how you'd get x by itself there. So now, let's look at this equation. If you solved that equation for x, what would you get? Yeah.
Negative 3 over 2.
Negative 3 over 2. And because we set that equation equal to 0, and that's the answer we got, what do we call that number again? Yeah.
The 0.
It's called a 0. It's also called a root, and it's also the x value of the x-intercept. Yep. It's all the same thing. You just have to get used to saying different words, because in the question I might say find the root, or I might say find the 0, or I might say find the x-intercept. And we can graph that. I mean, that's a pretty simple one. But if you graph 2x plus 3, you're going to notice it crosses at negative 1.5. That's the root that we just found. So now, if you take a step up from a linear equation, linear has an exponent of a 1. Now we're going to look at an exponent of a 2. What kind of equation do you call that when it has an exponent of, the highest exponent is a 2? Yeah?
Is it a quadratic?
That's a quadratic. When you draw a quadratic, the shape is a parabola. How many times can a parabola cross the x-axis at most? Remember, I gave you kind of a hint about how you figure out how many times it could cross at most. Yeah? Right. It can cross the x-axis up to 2 times, but it could also cross 1 time. We don't even really call it crossing. It's more like it just touches it. Or it could cross 0 times. And at the end of class yesterday, we talked about how b squared minus, or maybe it was yesterday, or I think it might have been the day before. B squared minus 4ac is a quick way to check how many times it crosses. Remember, this can come out to a negative number, a positive number, or 0. And those are your 3 cases. If it comes out negative, you've got this case. If that calculation came out positive, you've got this case. If that calculation came out exactly to 0, you've got that case. And that was at the end of section, say 1 point, it was 1.5. Yeah, 1.5. Okay, so let's solve this one. Now, this says to solve approximately. Whenever you see approximate, that means a rounded off answer is okay. If this said to solve exact, you would need to be using quadratic formula. That's where you get an answer like 2 plus or minus root 3 over 6 or something like that. But we don't have to use quadratic formula because rounding the answer is okay. So we're going to use the calculator. What do you think we're going to have to get this equation equal to before we type it in on the calculator? And we already did this on the last 2 problems. Yeah?
0.
We got to get it equal to 0. So I like to always keep this number positive. So I'm going to move everything to the left side. How would we move the negative 2x to the left? Yep.
Add 2x.
We would add it. And how would we move the 1 to the left? Yeah.
Subtract 1.
Subtract it. Okay. So now, if this said to solve exact, A is 1. I'm sorry. A is 2. B is 2. C is -1. I would plug those into the quadratic formula. But we're not using quadratic formula. So let's type that in on our calculator. So we have 2x squared plus 2x minus 1. I'll start with zoom 6, and if I don't see my parabola, I'll fix it. Okay, is that a good window? Yeah, I can see the bottom of the parabola. It's perfect. How many times does it cross the x-axis? Twice. Yep. So what we want to do is figure out exactly where it crosses. What do we call where it crosses again? That's the what? Yeah. The x-intercept. It's also known as the zero. We can calculate exactly where the zeros are. Press second, and then press trace. Which option there do you think is going to help us find the zeros? 0. Option 2. So I'm not sure we've done this before. I don't think so. So pick option 2. It's going to ask you 3 questions. First question is left bound. So pick a point somewhere to the left of where you think it crosses the axis. And once I put my cursor where I want it, what do you think I have to press? Enter. The next question it says is right bound. Put your cursor somewhere to the right of where you think it crosses the x-axis and hit enter again. Make sure when you do it, there's only one answer between the dotted lines. If you put your cursor too far to the right, then you're going to be trying to get both at the same time. Okay, we can't do that. And then we do our guess, and that is the first answer, -1.37. So if you got that, then you did it right. If not, then you did it wrong. So make sure you ask me. Now we'll do it one more time. Second calc, 0. Pick a point to the left. Go to the right. And again, the guess, you just put it kind of close, but it doesn't matter. I just have to make sure that I'm closer to the one on the right. And it gave me the other answer, 0.366. And that's how you get your 2 zeros. So that will definitely be something I ask you to do on the test tomorrow. Now, these you could get with quadratic formula. But I might give you a problem that has like a higher exponent in it that you wouldn't be able to do with quadratic formula. So you have to know how to do it on the calculator. Any question on how we got those 2 answers? Yes?
So you do second calc and do 0.
Yes.
And you go to the left.
Yeah.
You obviously can see it from
No.
there. My cursor's just it's like this. It's kind of showing the game.
Yeah, as long as it's like, if I was trying to find this one right here,
Yeah.
I need this cursor to be like up over here. That's to the left.
Okay.
And then if I want to find that, I need to put it to the right. I might put it like right about there. And then that's to the right. And now it's going to look right there to find the answer.
Okay.
And you got to do it twice because there's 2 answers. You can't do both at the same time. All right. So any question on how to calculate a 0? Okay. So in order to find a root graphically, we use second calc 0. On my calculator, it's option 2. If you're not using one of mine, it could be a different option. You might also see it called root. Okay, on the older graphing calculators, they didn't call it 0, they called it root. But it's the same thing. All right, so what you don't want to do is I saw some people in another class, they would press trace, and they try to just move the cursor till they think they're close to it. Well, no, that's not the way to do it, okay? Because especially all of a sudden you might notice the cursor kind of can jump sometime, and it makes it hard to get it exactly where you want it. So you want to do that. Second calc 0. Yes.
Do you have any tissues?
Just those paper towels right over there. Yeah. Okay, so this is one that you couldn't use quadratic formula for because it's not quadratic. So you have to know how to do it on the calculator. Okay, what's the first step to doing it on the calculator? Yes.
Set the equation to 0.
Set it equal to 0. Okay, so now I've got it equal to 0. What's my next step? Oh, it's not on yours.
Would we put it in the calculator?
Yeah, we got to put it into the calculator. So clear out anything else you have in there.
How do you write equals on the calculator?
You don't need to. The equal sign is always already there for you.
No, I mean like at the equals, or do you not plug that in?
Oh no, you don't plug that in. You just plug in what's on the other side.
Alright,
Yeah. So x cubed plus 2x minus 1. So we'll do zoom 6. And because this exponent is a 3, how many times could it cross the x-axis? Up to?
3 times.
Up to 3. This one doesn't. It only crosses once. Right? It kind of starts to come up. It thinks about turning a little bit. It's like, nope, and then it just keeps going. Okay, so it never actually turns. How do I find the 0 now? What do I press?
Second trace.
Second trace.
0.
And then option 2. Pick a point to the left, to the right, and do your guess. And that is your answer. Okay, if you're going to round to 2 decimal places, about 0.45. And that's it. Any question on how we calculated the 0? Now, if this isn't equal to 0 over here, then you're not calculating the 0. Like if you typed this in, and you forgot to move the 1 to the other side, then that's wrong. You got to put everything on one side first, then you type it. So, polynomials we've been looking at in the last problem. That's called a third degree polynomial. It's called a third degree polynomial because the highest exponent is a 3. And you guys have seen a couple different types now. You've seen one that kind of had a little bit of a turn, but it never fully made a turn like down and then back up. Okay, so some can look like this black one, but other ones look more like that blue one. And they don't always have to go down on the left, up on the right. You can reverse that. This one is reversed. This is down on the right, and then up as you go to the left. It's like a mirror image. Also, when you have a cubic, you don't have to have every one of those terms in it. The simplest cubic you could have is this one. That's the simplest one. In that case, B is 0, C is 0, D is 0. All those other terms aren't there. and A is like having a 1 right there. The more terms that you add in, generally the more complex the graph gets, and that's when it starts to do all these different terms and stuff. Any question on the general look of a cubic? So if you draw, let's say this is your window, and you draw a cubic, and all you could see was this, that would be a really bad window. Because pretend you can't see what's outside the box. All you'd see is a little corner of it here, and then a little kind of slice of it over here. You would need to zoom your window out so you could see more like that. Now you could actually see the turn. All right, let's try this one. Now, this has more terms in it, so chances are this one's going to be a little more complex when we draw it, meaning it's going to do more of those terms. Okay, so we've got x cubed minus 5x squared plus 6x minus 1. Okay, so the first question is, how many solutions does the equation have? It's already equal to 0, so I didn't have to mess with that. How many solutions does this equation have? Yeah. 3, yeah. When an equation is equal to 0, you are looking for where it crosses the x-axis. That's what equals 0 means, cross x-axis. Now, they want us to find the middle one. Now, just to be clear, I'm not saying that this one is exactly in the center of the other two. Maybe it is, maybe it isn't. I'm just using the word middle to mean I don't want you to find the left one or the right one. Find the one that's between them. Just using it to describe the one that I want. All right, so they don't want all 3, just the middle. All right, what do we press to find that? 0? Okay. Oh, second calc, okay. And then we go to 0, okay. And now we pick a point that's to the left of the middle one. To the right, now I can see the interval it's going to look in. And I guess it doesn't really matter. Just put it kind of close. And the answer is 1.55. Any question on that? So that's finding zeros of polynomials using the graphing calculator. All right, so last thing we're going to do, a little bit more on the calculator, is finding a complete graph. So remember what it means when you're finding a complete graph. It means you can see everything on the screen that's important. Now, what we're going to do in this one is we're going to solve one question. That's all that's left, one question. And it's a word problem. When you're solving a word problem, remember, you have to use a little bit of common sense. So if we're solving a word problem and it involves time, time can't be what kind of number? It can't be negative, right? So when we set up an equation and we put it in on the calculator, a lot of times we have to set the window so that it accurately represents our problem. Okay? Looking at negatives might not make sense. Sometimes it might make sense. Like if you own a business and you're talking about how much money you made, well then maybe it could be negative if you lose money. Right? That's different. But if you were tracking like how many jobs you did, like if you're a plumber, you wouldn't have a negative number of jobs. Smallest amount of jobs you could have would be 0 if you didn't have any work that day. All right, so let's look at this problem. So this problem says that Bill is going to invest some money. He has 2 different investments that he's going to split this money up into. Okay. He's going to put all the money in. But how he's going to break it up, it's up to him. Okay. Maybe he'll put 15,000 in one, 5,000 in the other. But he's got to put all 20,000 into these 2 investments. The way we're going to separate the 2 investments is based on how much interest they pay. So one of the investments pays 6.75% interest. The other one pays 8.6. Now, I wouldn't expect you to know what the formula is for simple interest right now, okay? Because that's it's a formula from banking or finance, so I'm going to tell you what it is. So we need to know what is the formula to calculate interest. To calculate interest, you have to multiply 3 things together. P, R, T. That's the formula. P is called principal, but that's the amount of money that you invest. R is the rate of the investment, but the rate has to be a decimal. So for example, if you had a rate of 12%, you need to make it 0.12. You need to change the percent to a decimal. And T, that's time, and it's usually measured in years. That's how long you keep your money in the investment. And generally, the longer you keep it in, the more money you make. Simple interest is the kind of investment where you never lose money. It's not like the stock market where you could put $5,000 in and tomorrow it's gone. That can't happen in this kind of investment. So we want to find an equation that represents how much interest Bill is going to earn in 1 year. So the first thing we need is we don't know how much money Bill is going to invest in each investment. But we know he has how many investments to choose from. He has 2 to choose from. Yep. Let's let X be the amount of money, that's the principal, that he puts in the 6.75% investment. Yeah, I don't know how much he's going to do, but I'm just going to call the amount X. So let's figure out how much interest Bill would earn in this investment if he invests that much money. So the interest is principal times rate times time. Okay, what's the rate of the 6.75% if you change it to a decimal? Yep.
0.0675.
Yep. 0.0675. Okay. So actually, you know what? Let me just put that off to the side for a minute. Okay. So keep that in mind. 0.0675. Okay, oftentimes I write it down and then I put it in my formula. Okay. So we've got our. That should be I equals. Okay, so we got the rate. It doesn't matter what order you multiply the three things in. You can do PRT, RPT, TRP. The order doesn't matter. So we got the rate. What's the principal? What's the amount of money being invested? X. We don't know. It's X dollars. We got the principal. We got the rate. And how long is Bill leaving his money in this investment?
1 year.
1 year, that's what it says up on the board.
Is it in years or months?
Years. Yep, in years. So let's multiply that out. And what you're left with is that. That's the amount of money Bill will earn in the first investment. We don't know what X is, so we can't answer that, but that's your formula. Now, that's just the interest from the first investment. He's still going to make some money on the second one. So let's figure out what we have here. How much money did Bill have to invest altogether? $20,000. So how much money does he have left to put in this investment? Because he already invested some of the money somewhere else, so he doesn't have $20,000 anymore.
Yep. 20,000 minus X.
Yep, 20,000 minus what he already put in the other investment. So that's my principal. What would be my rate? Remember, the rate has to be a decimal. Yep.
0.086.
Yep. 0.086. And again, the time is still 1 year. Okay. So this one, to simplify it, what am I going to do with the 0.086? Yeah. And what else? Well, the times 1, we don't really need that because it's just times 1.
And negative X?
Yeah, it's the distributive property, right? Yep. So we're going to distribute that out. We'll use our calculator. 20,000 times 0.086 gives you 1720. Minus 0.086x. So that's the amount of interest that Bill's going to earn in the second investment. Now, I know how much he's going to earn in the first one. I know how much he's going to earn in the second one. And now I want to know how much he earns altogether. So what do you think I'd have to do with the two formulas to find the total amount of interest he earns? Yeah, add them together. Okay, so the total interest is how much he earns in the first account, 0.0675x, plus how much he earns in the second account, 1720, minus 0.086x. So we're combining the two together by adding them. Are there any like terms there? Yeah?
The X's.
Yeah, the x's. So combine your like terms. 0.0675 minus 0.086. Negative 0.0185. And that's the formula for the total amount of interest that he will earn. You just have to tell me what x is. And x is the amount of money in the first investment, 6.75%. So if he puts $5,000 in that first investment, I could fill in a $5,000 right here, and I'll tell you exactly how much money he's going to make. Because that formula automatically knows if he put $5,000 in one, he put $15,000 in the other. It's all built into that formula automatic. Any question on how we got that formula? So we're going to use it to solve, to finish, and we're going to solve for x. But we don't know enough information right now. So I got to tell you one more thing to solve for x. Okay, and I'm going to tell you this on the next page. So I kind of talked about this already. Remember, we're graphing, this problem is about money. So we can't lose money. So negative money doesn't make sense. And we can't invest money for a negative amount of time. So we shouldn't be looking at negative numbers on the x or the y-axis in this problem. That doesn't make sense. Algebraically, sure, Could you plug in a negative number into this formula? Like, can you do negative 10 times negative 0.0185? Yeah, you can do a negative times a negative. Does it mean anything in this word problem? No, that doesn't mean anything. But mathematically, you can do it. But in the context of the word problem, no. Okay. So, last question. It says Bill earns $1,509.10. That's the total amount of interest he made for the year. So how much did Bill invest in each account? How did he split his money up so he earned exactly that amount? So we got our formula. We just have to figure out where the $1,509.10 gets plugged in. Where would that get plugged in? Two places we could fill it. Yep.
Where like I told
Yeah, the total interest. It's going to go right there. So $1,509.10 equals negative 0.0185x plus 1720. And how would we solve that algebraically? Would be our first step. Yep.
Subtract 1,720.
Yep. Subtract 1,720. For now, the negative 0.0185x is just going to stay right where it is. And take 1,509.1 minus 1720. Okay, negative 210.9. And what's our last? Okay. Yep. And what would you divide by?
0.0185. Never mind.
Yep.
negative.
Negative 0.0185. Okay. Now those negatives cancel, and we just have to see what we get when we divide. So we got 210.9 divided by 0.0185. That gives us 11,400. And what is that again? The 11,400 is, yeah?
The initial investment.
We gotta be a little more specific. Yeah? Still gonna be a little bit more specific. Yep. Which was the what percentage? Yeah, the 6.75. So this is the amount invested at 6.75%. But I still need to know the amount at, I think it was 8.6%. How would I figure out the amount at 8.6%? Yeah.
Subtract that amount from the like the 20,000.
Yeah, subtract that from the 20,000. And that would give you 8,600. Okay, so remember this question did say how much did Bill invest at each rate. So if you forget to do each and you only do one answer, then you've done like 95% of the work. You just forgot to subtract from 20,000 to get the second answer. Yep.
I thought that the like $15,000 one, I thought that was both the interest rates combined.
You thought what?
I thought that the equation with the 1720 in it, I thought that was both of the interest rates combined.
Yes. So this represents both combined, but x, the variable, only represents the amount invested at.
Oh, only invested in one. Okay.
Right. And that's what we defined at the very beginning, right there.
Oh, okay.
X is only the amount invested at 6.75. So any question on that one? Okay, so let me double check. So the first page, that's on 2.1, and a lot of that is calculating the zeros using the calculator. Yeah, finding the zeros. So you do need a graphing calculator for most of it. 45 though, we're gonna skip 45 on this one. So just up to 40. And then on page 88, 5 through 12. Yeah, I think that's okay. On page 88, this is really 3 questions, 31 to 34. That's a interest problem, like Bill investing money. So I'll make sure I put the list of topics on the board, and I will be after school today for extra help.